like I said, feel free to interrupt me. Don't think you can't ask questions just because I'm recording. So today we're talking about section 5.4, which is called the fundamental theorem of algebra. I've got the fundamental theorem of algebra up there on the board too. So if you want to copy that down, I've got it shortened, like as short as you can get it, or as, you know, summarized as you can get it. It says every polynomial equation of degree n has at most, that part's important, has at most n zeros. And just a reminder, zeros, these are the same things as your x-intercepts. So just another name for x-intercepts. And remember, the degree is the highest exponent when you're looking at your polynomial. So that means if you have a polynomial that's degree 3, it's going to have at most 3 x-intercepts. So I'm going to give you all a second to write that down, and then I'm going to explain what the words at most mean. Every polynomial equation of degree n has at most n x-intercepts. All right, so let's talk about what at most means. Let's say that I told you, okay, I have some cash in my wallet, but at most I've got $20. At most I've got $20. What does that mean? At most $20. It'd be $20 or less. Same thing here. So if it has degree n, it's going to have at most n x-intercepts, so it could be n, could be less. So again, if it was degree 3, you would say, okay, well, at most it's going to have 3 x-intercepts. It could have less. And we'll talk about why it might have less in just a minute. I'll show you, I'll draw a little picture for you. And then I have this last theorem that you have to copy down. This will be the last big chunk of writing we do today. Linear factor theorem, super useful theorem. It says that if you know the x-intercepts of a function, then you can construct that polynomial by using the form x minus c. So each factor will have the form x minus c, where c represents the x-intercept. So every polynomial function is going to have the same number of factors as its degree. So factors, that's going to be, like if your function is f of x equals x minus 1 times x plus 2. This would have 1, 2 factors. So that means it must be degree 2, because the linear factor theorem tells us the number of factors is equal to the number of degrees. All right, so every polynomial function has the same number of factors as its degree, and each factor will be of the form x minus c, where c represents the x-intercept. And the minus is important. We've dealt with this a couple of times at this point, the x minus c, and that's, we'll see in just a second how we might have to adjust for that minus in there. Just like before, we'll just change those pluses to double negatives. That's how we'll adjust for that. All right, so I wrote just a little example of a polynomial function here, a really basic example, and then we'll just talk about what those two theorems tell us about this function. The fundamental theorem of algebra and the linear factors theorem. I didn't really love the homework choices that were in Hawks for this section, so the homework's like super short. think it's only 2 questions. So whenever we get to that, I'll tell you, like, okay, this is what the test question is going to look like. So since, like I said, there's not a lot of practice problems in this section. All right, so let's take a look at this polynomial. F of x equals x minus 1 times x plus 4 times x minus 3. All right, so first of all, we can tell that this has 1, 2, 3 factors. So these are the factors. Since it has 3 factors, it must be degree 3. So that tells us it's a degree 3 or a 3rd degree polynomial. And then the last thing that the linear factors theorem tells us is we can super quickly identify all of the x-intercepts if it's in this factored form. So remember, it has to be in the form x minus c. This one's okay. This one's okay. This one you would have to go in and change that positive to a double negative. So change that positive to a double negative. And then you could quickly identify, okay, well, -1, so here, -4, that's not -1, I'm sorry, +1. X matches with X, minus matches with minus, 1 matches with C. That was my bad, sorry. So +1, this one is -4, because X minus C, so that would be C is -4. And then the last one, X minus C, so C must be 3. Those are x-intercepts. And then we can just confirm by the fundamental theorem of algebra. It says every polynomial equation of degree, in this case 3, has at most 3 x-intercepts. So, and it does. That works out here, degree 3, 3 x-intercepts. All right, so super basic, but this gives you a way to quickly grab the x-intercepts if you're in factored form. All right, so let's talk about what happens if one of these factors has an exponent on it. So if you have like a 4 up here in the exponent, or a 3 or a 2, how is that going to change your polynomial? So let's consider this polynomial here. F of x equals 3 times x minus 1 times x plus 2 squared. Now, you could make this look just like the last polynomial, just by writing out, like, okay, well, f of x equals 3 times x minus 1, x plus 2 squared. Remember back when we would like FOIL stuff out, we would write it as x plus 2 times x plus 2. And now it perfectly matches up with the polynomial we just did. We could grab the x-intercepts out of here. That would be 1, -2, and -2. All right, so there's your x-intercepts. And then you could also look and say, okay, it's got 3 factors, so it's degree 3. But whenever you're in this factored form like this and it's got it raised to a power, that brings up a topic called multiplicity. Multiplicity. The multiplicity of a factor. The multiplicity of a factor or an x-intercept just refers to the exponent. So it refers to exponent on that factor. All right, so in our first factor, right here, looking at this top line, in our first factor right here, this one, it doesn't have an exponent indicated, so we can pretend like there's a 1 there. So it would have multiplicity 1. That's how you would describe it. And then this next factor, it has an exponent of 2. It would have a multiplicity of 2. So super simple. What you would need to know for like a super quick way to write this on your, or short way to write this on your index card is, not index card, sorry, on your formula sheet. I used to do index cards. How you could summarize this on your formula sheet, you would just say multiplicity, that's the exponent on the factor. All right, so the multiplicity is the exponent on your factor. Now, the multiplicity of a factor has an effect on the graph. I'm not going to test you over this next part, but if you go on to calculus or a higher math, you may need to know this, so I'm just going to mention it to you. So if you are graphing a function, then, I don't know why my Zoom doesn't want to work. So if you're graphing a function and it has even multiplicity, one thing's going to happen on the graph. If you graph it and it has odd multiplicity, something else is going to happen. So make yourself a little table here, even multiplicity, odd multiplicity, and then we'll write a little description of what's going to happen on the graph. And then I'll pull up Wolfram Alpha on the computer and we'll graph this because I don't have my calculator today. So even multiplicity, factors with even multiplicities or x-intercepts that have even multiplicities, let's see, I always have to keep this straight in my head. Okay, odd is cross. Even multiplicity, so we'll say x-intercepts with even multiplicity your graph is going to bounce off the x-axis. So it's going to get really close to the x-axis. It's just going to touch it, and then it's going to bounce back off. So if you have an x-intercept with an even multiplicity, your graph is going to bounce off of the x-axis. And then for odd multiplicity, so for x-intercepts with odd multiplicity, the graph will just cross through. So the graph will cross the x-axis. It'll go straight through. And then your book also describes it and says, okay, if it has even multiplicity, the y values do not change sign. So y values don't change the sign. Like if the y values are positive, they stay positive after it passes through that x-intercept. And then for odd multiplicity, the y values do change sign, which makes sense because it's crossing the x-axis. So if it's crossing the x-axis, it's going to go through and either go from positive to negative or from negative to positive. All right, so if you have your graphing calculator, go ahead and take it out, and we will graph this real quick. And just to show you a visual representation of what does it mean to bounce off the x-axis. And of course, we know what it means to cross the x-axis. Let's see if I can make this bigger. Okay. All right, I'm going to go to Wolfram Alpha because, like I said, I don't have my calculator today. But go to your y equals screen and just type in your function. That was that f of x equals 3 times x minus 1 times x plus 2 squared. Wolfram Alpha is like an online calculator. Super helpful. I'm going to graph that, and there we go. This is what yours should somewhat look like. We can plot it. I'll just say if I'm smart enough to figure that out. Okay, so just trying to make the graph look like y'all's. Yeah, there we go. All right, so this is what yours should look like. All right, and we said we have x equals, just looking at my function, picking out my x-intercepts, I've got positive 1 and negative 2. All right, so here is your x-intercept at negative 2. Here's your x-intercept at positive 1. So let's look at our function. The x minus 1, that factor, we said that it has an exponent of 1. Just so you know what I'm referring to, I'm talking about right here. So there's no exponent indicated right there, so we assume it's a 1. So that means it has odd multiplicity, which means it should cross the x-axis at 1. And it does. You can see it right here, it crosses. And then at x equals negative 2, it has a multiplicity right here of 2. So even multiplicity, 2 is an even number, so it should bounce off. So you see that it's increasing, it bounces off the x-axis, it starts decreasing again, but it never changes the sign, so it never crosses over and becomes positive. All right, so that's what multiplicity means from a graphical standpoint. Like I said, that's not something that I'm going to test you over for this test, but just in case you use it in another class, I wanted you to have at least heard it before. Now here's what we're going to do on the next test. This will be the question from this section. This is what the homework looks like as well. We're just doing one example because these are pretty easy. They're not overly complicated. Let's see if I can get it to, okay, it says it's zoomed all the way out. Oh, it's because I have this done. All right, there we go. Construct a polynomial function with the following properties. And then we've got 4 bullet points here. Sorry, I got that zoom thing in the middle of the screen. Oh, okay. That was a close one. There, now we got everything in the screen. All right, 4 bullet points. This is exactly what it'll look like on the test, and then I'll just switch the numbers around a little bit. So 5th degree, 2 is a 0 of multiplicity 3. So 2 is the x-intercept, and its multiplicity is 3. It says negative 3 is the only other 0, and the leading coefficient is 2. So I'm going to go through bullet point, each one by itself and tell you what each of those bullet points means, and how we can use that information to construct our polynomial. All right, so we're going to put a little star beside this because it's on the test. All right, so 5th degree, we already know that all of our factors, there should be 5 factors, basically. And another way to say that is that all the multiplicities, so all multiplicities should add to 5. Because there should be 5 factors altogether. So all of the multiplicities need to add to 5. Positive 2 is a 0 of multiplicity 3. We're going to use the linear factors theorem for this. That tells us our factors have the form x minus c, where c is the x-intercept, or the 0. All right, so here's our value for c here. 2 is going to be our value for c. Multiplicity is 3. That's going to be the exponent on our factor. So that's going to be the exponent on our factor. And then it says negative 3 is the only other 0, so that'll be another value for c, another factor. And then leading coefficient is 2. That means we'll just stick 2 right in the front. All right, so let's start constructing our polynomial. We'll just call it f of x. Doesn't matter what you call it. You could call it p of x for polynomial. I'm just using function notation because they use the words polynomial function in the problem. All right, so let's see. Leading coefficient is 2. Go ahead and write that in the front. All right. Let's go ahead and construct our first factor. All right, so 2 is a 0 of multiplicity 3. All right, so if our factors have to have the form x minus c, where c is the x-intercept, that's going to be x minus 2, and it has a multiplicity of 3, so that's going to be the exponent on that factor. And then our last 0, it says negative 3 is the only other 0. All right, so again, it has to have the form x minus c. So c in this case is negative 3. Go ahead and change that double negative to a positive. So change that. And we have one last thing we need to do. This was supposed to be degree 5. All the multiplicities were supposed to add to 5. So what should be the multiplicity here? 2. Yep. So I'll just write a little arrow here and write what I did. It had to be whatever the multiplicity is there plus blank equals the degree, which was 5. And so you just solve that equation from there. And then you're done. This is it. So you don't have to multiply this out or anything. You can leave it just like this. This is the answer. It's not incorrect to multiply it out. It's just a bunch of work for no reason. So this is exactly what the homework will look like. This is what the test will look like. And I will just change the numbers. Like I might make it a 6th degree, make one of the multiplicities 4, and then change the zeros or something. But otherwise, it'll look exactly like this. All right, let me stop the recording. We're done. And then I will talk about the test.